So basically, a society has over 800 members. Most of those in the UK. Sorry, 8,000 members. Most of those are in the UK, but there's a big proportion outside of the UK in lots of different countries, including the US and Asia and Europe, etc. It's 180 years plus old, so it's a well-established society, and Charles Babbage was one of its founding members. So on the one hand, we have a distinct heritage and gravitas, but on the other hand, we're a forward-looking society where we're looking to exert a lot of influence. And just some examples recently where we've exerted some influence was giving evidence to the Science and Technology Select Committee on algorithmic responsibility. Our call for the Council of Data Ethics was included in the Conservative Manifesto. And I've already said this sort of joke, but essentially we're not responsible for any other parts of that manifesto. We recently teamed up with the Turing Institute at the Cheltenham Science Festival on the subject of does the algorithm know best? So the RSS has always been a very broad church, and it's been led by eminent statisticians such as David Spiegelhalter here, who obviously corrected my 800 to 8,000, so you can see the sort of eminence that we have. And you might well have seen him on TV recently, on the news about the election and his famous book, Sex by Numbers. So, but we have statisticians that are interested in data more generally. Harold Wilson was an MP, actually an MP in my constituency back in Huyton in Liverpool many years ago. And if you take a look on the side here, you'll be able to find your favourite RSS president somewhere along the line. So RSS has always been a broad church, and it's just a pleasure to have everybody here today. So jump forward to the agenda. And it maybe looks a little bit formal, but there's going to be a lot of time at the end for a Q&A. So we're going to start off with the introduction from me here. We're then going to touch on the 12 questions, which is going to be presented by Harry and Fran. And these are basically 12 questions that we think the data science section should look at over the next few years. And we really want your views on whether we've got the right questions there. We're then going to have an illustration of what a data science section, how it might go about addressing one of these issues. So Martin is going to present on that, and he's had some input for some other people as well. We're then going to have 3 responses. So one from Tom Smith at the ONS, one from Juan Hernandez, who's at Kantar Millward Brown, and then one from Sophia at the UCL. So they represent essentially government, industry, and academia. We then have David Spiegelhalter giving a brief response on behalf of the society, and then we're opening up for a Q&A where we really want to hear your views. So a lot of the things we're putting up today are essentially a straw man, and we want to engage with the wider community.
You start a data science section, you've got to wonder what it's for and what it's trying to do. And one of the things that we thought was interesting and worthwhile to do was to think about how data science grows over time and how we as a section can be part of that growth and can help shape that growth. Because it's one observation at the moment that data science is like a kind of a cottage industry, right? It's done by little groups of people in organizations, loosely related to other kind of professionalisms within those organizations, but often kind of driven by kind of personal experience, personal expertise, exploration of what's possible. And over time, for data science to really have the kind of impact it needs to do, we're kind of thinking maybe it's interesting to think about how that will professionalize, how that will industrialize, so that we move on from, you know, the equivalent of people spinning yarn in their cottage to actual big factories producing this stuff for the value of society. Now, why that particularly matters and perhaps why that is in some sense different to some other areas that have developed over time is that data science transforms analytics from being some kind of CEOs and leaders might think of some kind of peripheral analytic activity, a reporting activity, something where you do something, then your analysts tell you what you've done, to being a cost center, to being a core revenue generating part of a business or activity, right? We're increasingly seeing companies like Amazon where data and analytics is actually at the center of driving them forward, right? It's not just something on the edge, right? It is their product. And as that's the case, businesses where their product is relying on these things will start thinking about how can we professionalize, industrialize this activity. We as the data science section are really interested in shaping that debate, becoming an important part of the creation of this new industry. Now, in order to do that, we're sort of thinking that organizations that succeed in transforming from where they are now into really making a difference with this new data science thing, and something that we can immediately be being part of forming for them is sort of three things: clarity, strategy, and how to implement these things. And in some sense, that's what these questions, these 12 questions we've come up today, are all around. How can we help give organizations clarity about how to envisage data science as an institutional activity with a coherent structure and a common understanding of itself? Lots of people thinking of it in lots of different ways, but until the world can know who we are in the way that it knows what a statistician is or what an analyst is and what those people do, until there is that coherent clarity about what they are, it's very hard to imagine that it's going to be adopted in the way that we hope and expect. Secondly, we think it needs to be able to show its value. And again, some of the questions are around how can we create a corpus of knowledge and a set of understandings and workflows that allow organizations to adopt this thing because they understand how it's going to add value to them beyond just the vague promises. And thirdly, what are the practical challenges of an organization that kind of knows about analytics, maybe knows a bit about statistics, but there's this kind of relatively new breed thing of data science that throws it all up in the air and combines it. How practically can you find these people, get them into your organization, and then make a go of it and actually make a success of it? Those are the kind of themes behind these 12 questions. So if you start getting lost in what they all are, that's kind of what we're trying to get to. Fran.
Thank you. Starting in to look at these questions. So, as Harry said, we've defined 12 pretty big and pretty common questions, none of which are simple. That's why we've framed them as important questions. And truthfully, the answer to all of them is it depends. So the point of trying to explore these questions in more depth is to really get into what does it depend on, what are the patterns of success, what are the patterns of failure, try and build up a much better understanding of how to get this new cross-cutting thing working very well in organisations of all kinds. And part of that for these big questions is about engaging with what your aims are. So we've said here questions like, well, what does great data science look like? What is that? What are some stories about it? And how does the workflow work? Particularly if you're in a big organisation, it's not all in one person's head. How does that flow from one place to another? What kind of problems can it address? So potentially, in theory, touches everything. What are the problems where it's likely to have impact? And as a data scientist, taking it a step up, what are your responsibilities to wider society, not just within the organisation's context, but more broadly, what impact might you have? So all of these are very big questions, but they're ones which we think the RSS and this group can push forward a bit by actually starting to bring together some examples of what works, bring together lots of different types of experience to try and form a more coherent picture. And Harry, if you want to talk about the next few.
So if you're going to do data science, you're going to need data scientists. But finding these people is one of our key challenges. Creating them, finding them, developing is a key challenge to development of the industry as a whole. A data scientist, even though we haven't kind of defined it, seems to need to do a number of things, from computation to mathematics to statistics to communication and visualization. There's a whole load of sort of things that we kind of think of as being part of this data science curriculum. And below that, they need a set of attributes and qualities that aren't simply skills, but are kind of who they are, not just what they know. So how can you define what that data scientist will then look like when you're looking for them? And that will help us understand, those of us who are data scientists, where our gaps are, where we need to develop, where we need to push ourselves forward if we're going to be truly world-class. Beyond that, once you started thinking about who these people are and what they should be aspiring to, we need to be thinking about how we create careers for these data scientists, right? So it's not just enough to find one and put one in your business, or 10 and put 10 in your business, but how do you create a career path for that person that allows them to, I don't know, buy a house, right? And think about themselves as a data scientist long term, not just got someone who is doing data science right now. How do you develop these people, particularly given that these guys are often autodidacts, right? They've learned themselves how to do this thing. In what sense can there be some kind of curriculum or career plan for them? And then crucially, when you're thinking about data scientists and what we offer them long term, how can they participate in the value that they create? And how can they measure that value? Because there's going to be plenty of people out there making a lot of money and value out of this data science, and I'm hoping that the guys that create it will in some sense benefit from that. Fran?
So important questions for data scientists on the previous group of questions, and then going back to the organizational perspective, if you're a business or an organization trying to get started on it, how do you get going with data science successfully? And by the way, the reason we've had all of these questions defined as key questions is they're ones that we all argued about. So they're all ones that of the existing committee no one can agree on. So we know that they're important and knotty. How to start a data science function is particularly one that's present to lots of people's minds at the moment. We know a fair bit about what doesn't work. There are quite a few of what software developers might call anti-patterns, so superficially appealing solutions which tend to end in disaster. So the pattern, for example, of the lone data scientist who's been brought in to be parachuted into an organization on their own with no particular resources or mandate to do magic. We know that doesn't work. But what does work? You know, what does the team look like? What does the mandate the person needs to have look like? Is it a person? Is it people? Which function do they even report into? So they have to cut across business and technology. Whichever one they report to, they're going to have a tension with the other one, so you end up with some unholy matrix system. How do you resolve these things? We know that there are no neat solutions, so we know that there's a lot of good practice to figure out to make this work well. And then once you have managed to industrialize data science, how does it fit into the organization more generally? So as a cross-cutting thing, which inherently we, at the moment, certainly is quite innovative and quite creative, how does that sit with a big organization and with an industrial process? We're not quite sure yet, but we know that we need to start to move towards much clearer answers about all of this. So some big, interesting questions which we want to call on all of your experience to start to answer. And Harry.
So you've talked about getting data scientists and initiating your data science activity. But then there's kind of like the longer term questions. So how should businesses, when I say business here, I actually mean any kind of organizations. I say business, that's the background I'm from, but it could be government, it could be not-for-profit. How can business practices change to make a success of data science? So quite often, you know, you come across organizations that say, well, there's this great new technology or great new interesting thing. So what we want to do is bring some people in and we want them to change completely what they do so they fit in with what we already do. This is not how Amazon, Google, all those kind of guys, that's not why they're making a massive impact on the world. They're making a big impact on the world because everything they do is driven by this realization that data and technology can be at the core of their business. Now, that's all fine if you're already Uber, right? But if you're Barclays, which is where I'm from, how do you reconcile the fact that you have an existing business model, an existing way of doing things, but you need to change these things radically in order to make a difference with them? How should a business engage in that process of thinking about themselves anew such that data science can have an impact for them? We as data scientists must have a crucial role in beginning to answer those questions. Secondly, we often get told as technical people that we need to be better at explaining ourselves to non-technical people. The onus is all on us. Well, My suspicion, and I may be wrong about this, and we've talked about this in the group, is that the boot may gradually be coming onto another foot. Because if you, as, for example, the leader of a bank, want to think of yourselves as a data-driven organization, you kind of got to know a little bit about data. You kind of got to know a little bit about what you're doing with data. If you went to speak to, I don't know, Mark Zuckerberg, right? He's going to be able to have a conversation with any of you guys in the room, right? It might be a bit more techy, a bit less statsy. He's going to be able to engage. And yet, think of all those managers and executives out there who just simply wouldn't know where to start. Those guys are going to need some help, right, in understanding, in changing, in learning and growing in order for them to deal with the age that is about to hit them, which is, I think, driven by a lot of this stuff. We are going to need to start to scope out a curriculum for business schools, not just for MSc in data science. We need the business schools to be thinking about data science. How does a chief executive critique some kind of data science product put in front of them? Right? How does a mid-level manager ask whether your model works or not and understand the answer they've got? In an era where these things actually matter to their core business, not just to some reporting function, this is going to be important, and we need to be scoping that if we want data science to kind of fit into these big existing organizational structures that we have in our society. And then finally, this is kind of a little one of mine because particularly in my head at the moment, I'm thinking about it in my business, but I think it's important. How do we move from data science as just a collection of projects, right? As us doing clever stuff, transforming our business, yes. Building new things, yes. Being exciting, yes. But how do we move from a collection of things to a coherent business in the way that business intelligence is now a coherent function. Finance is a coherent function of a large organization, right? Marketing is. How do we move from data science just being a bunch of projects to being a core revenue-driving, in a business, revenue-driving capability of an organization? In particular, the technology is moving incredibly fast, right? How do we think about moving technology, changing environment? How do we incorporate that into something that needs to be able to be here next year, the year after that? So that's loads of kind of interesting questions that we've hopefully distilled into 12, right? There are probably more out there. Fran.
So we've given 12 big, interesting questions, and we haven't given you any of the answers today. But we think these are really important ones that need digging down further into. So what we would really like to do next is work with the people in this room to try and help take data science from an artisan phase into that industrial phase and do it successfully, ethically, effectively, all of those good things that we would all like to see happen. We think there might even be a working group around each of the questions, so if there's one thing that particularly resonates with you, that would be fantastic. The way to get involved would be through the Slack channel, which is linked here, and I suspect will be circulated via email later. Yeah, I'm getting a nod. It will definitely be circulated later. So please have a think about these questions and what you think about them personally, because many different perspectives are needed to get this right. And thank you very much.
Thank you. Get involved.
So Fran and Harry have spoken about the 12 questions that we think are interesting in the data science section, but how are we going to concretely go about answering some of these questions? And most importantly, how are we going to bring the knowledge of the community and the wisdom of the data science community together to start building some good answers to these questions? So I'm going to talk, I'm going to grab this thing. Okay, so I'm going to talk about this topic, and really this presentation is just an example. It's just an idea of a way that we can bring ideas together, start disseminating some best practice. I mean, it's just an informal talk or maybe a blog post that we could publish. Maybe it's the starting point for something more formal, maybe a best practice guide or something like that. But it's really just an example. And it's just a draft. It's aimed at junior data scientists, maybe intermediate data scientists. And it's had input from these data science leaders, some of whom are in the audience. But really today, I want to open this up to everyone in the community, really. I mean, this kind of thing is just going to be improved by as many ideas as possible from the community, I think. So this is the question that I'm interested in. What does a good data science workflow look like? I'm looking at one tiny aspect of that. So I'm looking at how do you prevent simple errors in data science pipelines. Could be the most boring topic I could have chosen, but there you go. Okay, so this is a paper from 2001. This is the publication of doesn't really matter what it's about, but it happens to be the publication of a crystal structure. So it's a three-dimensional structure of a protein, this protein MSBA, 2001. It's published in the journal Science. Really high impact paper, had a big influence until it was retracted in 2006. And it was retracted for this reason. You can read this. Basically, there was a script that had to rescale some variables from this scale, the I scale, to this other scale, which is the F scale. But if you look closely, you can see that they converted the I plus and I minus to F minus and F plus. They flipped the column. So the scaling script works perfectly, but it's flipped the column. So the F minus ended up in the plus column, and the F plus ended up in the negative column. It should have been like this. So it's kind of a simple error, probably the kind of error that all of us have made at some point or another. Unfortunately, this paper was cited 750 times before it was retracted. There were another 4 papers, so there were 5 papers in total that had to be retracted. They all used the same script. And 3 of the papers were published in Science, actually. So these papers had a massive influence on the field. Lots of grant proposals were either rejected or accepted because of them. It was a complete nightmare for the field. So this next example is from some guys called Keith Bagley and Kevin Coombs. Similar story. They spent years doing very detailed forensic work into the papers published by this guy Anil Potti, who's a researcher at Duke University. Eventually, they were able to force the retraction of 4 papers, but then that was followed by a slew of other papers that had to be retracted. 3 clinical trials were shut down, and then Potti was forced to resign. So that was a bit of a nightmare. And this is one of the things that Bagley and Coombs said. They said lots of the problems were to do with things like off-by-one errors, column switching, people misunderstanding the meaning of a flag. Basically, what they said were simple errors. So that's in academia, right? So in academia, the norm is transparency. Everyone publishes their data or code, or they're supposed to anyway. At the least, they publish their papers. I believe that this problem is probably much worse in industry and generally outside of academia. So this is a real-world example. This is from a government agency. Somebody anonymous told me about this. So this is the project. So the project was to discover individuals at high risk of a certain event. Doesn't matter what the event is. They use a really sophisticated machine learning classifier to make this prediction. And it works really well. After 6 months of R&D, they had great accuracy. They could predict this event really, really well. And it was going to go into production. Everyone was really, really happy. But during the productionization process, they realized that they were actually predicting the wrong outcome variable. They just looked at the wrong column. It's easily done, like myself. The problem was that when they found the correct column that they should have been looking at, that column only had 35 positive events. So they couldn't train their fancy classifier anymore, and the project was failed and was cancelled. It was embarrassing. So, what went wrong? So I think the main problem here is that the attitude within the team was, it's a machine learning classifier, we don't really need to understand the model, we don't need to understand the data, it just kind of works. They didn't do any communication with the people who actually produced the data. The people who produced the data sent them an email with the data file, and then 6 months later, they came back with the results. So I think that's a problem. And I think that they use this really fancy machine learning classifier because it wins loads of Kaggle competitions. It's a powerful classifier. In the right hands, it's a useful tool. The problem is in Kaggle competitions, you don't get flipped columns or mislabeled data. You don't need to deal with problems like that. So those 3 stories of failure. What do we do about fixing it? So I'm going to show you just a few ideas for things that you can do to fix these problems. And I believe that if everyone followed these simple principles, these kind of errors wouldn't happen. Other kind of errors would happen, but not these ones. So this is what I mean by simple errors. Column switching, columns mislabeled, columns not aligned properly, off by one errors, things like that. First of all, I think if you start with the idea that there are going to be problems in the data, there are going to be columns that have been switched, you're going to be in good shape. It's a good approach. So I think you should be, I mean, I know that for most of us in this room, this is common knowledge and goes without saying, but for many junior data scientists, I don't think this is common knowledge. You really should be confirming your results using multiple data sets. You should be using multiple algorithms. If you're really paranoid, you should probably program your algorithms in different programming languages. I do that. So triangulation, as data science techniques goes, quite old. It's published in 1533, so I'm hoping we'll start to see its widespread adoption. Coding standards. These things are table stakes, I think. You know, unit tests, code reviews. If you think something's true of the data, then you should test it, and that should be an automated test every time the data's changed. So this seems kind of obvious, right? So, but you know, this is not actually taught on most machine learning courses or statistics courses, as far as I understand. So that's coding standards. How about data standards? Practice reproducible science. If you output with all of your results how you actually made the data so that the data can be reproduced, that's a good start. If you can count at every step in case something goes wrong, I mean, stuff always goes wrong at joins and filters. If you don't count and log at every join and filter, you can assume that your data is garbage, in my opinion. So this next one comes from Bagley and Coombs. They suggest to have human-readable data. So don't use numerical flags like 0 and 1. Use sensitive and resistant. Use human-readable language. That's saved my life many times. Cultural standards, though. You know, peer review, formal lab meetings. These are things which are really common in the academic world, but they're not that common in industry, I think. Some kind of formal, structured way to hand over data, I think, is a really good idea. And really important is to encourage people to find bugs and celebrate it when people have found data bugs and don't criticize people. So if this looks like hard work, probably should. So this reminds me of this quote by Ernest Rutherford about Hans Geiger. He says, "Geiger worked like a slave. He's a demon at the work of counting scintillations and could count at intervals for a whole night." And that thing, have we got a laser thingy here? No. So this contraption is a scintillation machine, and Hans Geiger, who's on the left, used to have to look through that tube thing for hours, all night, and just count flashes of light. That was his job. But it was hard work, right? But they discovered the atomic nucleus, so it kind of paid off. And I think that's what real scientific work looks like. It's really painstaking, and it's really, really difficult. I think it looks like that. I don't think it looks like that. These are my references. Thank you.
So I thought, being an academic, I always have to start with a definition and going back to the basics. So we're talking about data science here today, and we all know what data science is. But I wanted to draw back again on the exact comments made earlier today about the strong interdisciplinary nature of the area, where people have to start by drawing upon many different disciplines, including statistics, machine learning, systems in computer science, databases, and applied mathematics. And secondly, one of the other big things that makes it quite different from the types of data we're all used to handling is that it's strongly multimodal. It has to handle lots of different data. What's the consequence of all this? Well, if you think about the topics you might need to know about in order to make a good and expert judgment about how to handle data, the list just becomes absolutely impossible. And I think that's why we get that beautiful picture of the unicorn, because there's absolutely no human being who's capable of being an expert in all of these areas, ranging from maths, computer science, to statistics. So I think the answer to what are the characteristics of the ideal data scientist needs to be collaborative, because there is no way any human being, possibly an artificially intelligent machine might do it, would be able to understand and utilize all of these different techniques at the same time. So I think one of the important things is being able to reach out to different disciplines. And yes, we have our starting point of statistics, but we need to be open and collaborative with people both in application areas. And I therefore really appreciated the speaker before me who mentioned the importance of taking results back to the application domain and checking the common sense of the results that come out on the other side. So I think we all have this sense that the ideal data scientist doesn't really exist. What does exist are collaborative teams. What's really different about data science from what's been going on before? Well, I think we're more and more in the setting of ubiquitous sensing. That means we're getting a lot of data that's collected automatically. And everyone like me who harken back to the Stone Ages and we're taught about box and experimental design and all of these things, we've slightly become dinosaurs. And what we'll need to do is to figure out how to analyze data given it wasn't collected with a specific purpose in mind. And another way that makes us all slightly mistrained, if you come from the same background as I, of a mathematics degree, is that all of this is human subjects data. So if you're social statisticians, you're already experts at this, right? Because you already know that you need to be quite careful with how you handle human subjects data. But this instead creates a lot of new issues where people have to worry about handling it correctly. There's not going to naturally be a clear and clean-cut sampling paradigm. And I think we've all criticized in various times the problem with thinking that we have all the data and we don't have any uncertainty left. There's a huge issue with this ubiquitous sensing about getting bias from the lack of design. We've all heard about Twitter data coming from Hurricane Sandy, giving a very skewed and biased view about where problems were arising. The Street Bump smartphone app that only found potholes where people had a lot of iPhones. And all of this comes back to being really challenged to be able to generalize results out from the data sets that we've already observed. And one of the cases where this might really become a big problem is the notion of precision medicine. Another area which really touches on a lot of things I've become interested in, and I'm probably starting to reach the end of my 5 minutes, is as we start to use data science to make decisions, all sorts of new responsibilities come upon us. So we really have to worry about transparency. We have very large amounts of complex data. And as the gentleman who spoke before me just discussed, if we have very complex algorithms on top of that, how are we going to be able to justify that the decisions we make are fair and equitable? And what does even fair mean? What you see on the right-hand side are two very well-discussed examples. One of them of using car insurance, which is different depending on your gender. And the second is the US example of Compass, which uses an analytic system to decide on if you're going to get parole or not. And ladies and gentlemen, in Yorkshire, they're using a variant of an algorithm to decide on whether to release people on bail. So you can't just say that's only going on in the US. So I think all of this is going to put new challenges in how we teach, because unless you have the people who understand the algorithms, who are trained in an academic setting to really engage with how the decisions are being implemented, we could end up having a very dystopian society. And I think on one hand, you really have the academic world trying to rise up to this. So here are just a few recent sort of different developments that are trying to understand what is fair and just. If we make systems that make decisions, how can we really design these so that we have a really good set of systems rather than questionable automated decision makings which are justified by the computer says no or the computer says yes. So I really picked up on the question of should there be an explicit data science code of ethics and behavior. And finally, just being naughty, I'm going to take a half a second and advertise a conference that I organize every year, which is on the theory of big data. Thank you.
My name is Juan. I work for Cantor Millward Brown, who is a operating company within Kantar, which is a massive insights and media conglomerate. It's an institution. Well, it's an institution of about 30,000 employees globally, and that should give you an idea of just how painful it has been to speak data science at a company that's been around this long and is that size. I found it really compelling to read the 12-question paper. I thought somebody had x-rayed my brain for the last 2 years and just captured that on paper, because those are exactly the type of questions and issues that we're dealing with on a daily basis. And to me, the really big issue we're trying to address, at least in our group, and that I've seen other competitors especially try to deal with, is defining it at a very strategic, high-level instance. It's really hard for the people on the ground doing the really cool stuff, the really good science data projects, to get any sort of leverage, any sort of traction that can guarantee the things that the business is ultimately chasing: scalability, pace, innovation, quality of research. All that comes along with this massive influx of data, massive influx of skills getting mixed up for the first time. And businesses can't really figure out how to define a data scientist, how to hire a data scientist, how to make data scientists part of the business. So from our perspective, we're really still struggling with that definition. And from it, when you start to look around the business, you have to reconcile certain realities. So you have a team of data scientists or statisticians who may not have written any sort of production code in their life. You have a technology team that has, up until this day, been the sole source of production code within a business. You start to get into muddy waters like data and privacy, not to mention security, infrastructure, platform. There's all these components that have to come together for a business to really be able to scale data science, that without support from the top, it's really, really difficult to achieve. I mean, some of the things that we've been talking about are focusing specifically on the interaction with technology departments. We are trying to build a capability focusing on providing our data scientists with a platform that will allow them to forget about everything that isn't data science proper. If you don't think about it that way, and you start to think, and you give this unicorn data science a big project, they'll need to come in, they'll set up servers, they'll set up databases, they'll perform your analysis, they'll write the code, they'll deliver insight, produce amazing deliverables, and then you realize that a hacker got into the system and half your data is gone. All those sort of things are the things that this idea of collaboration really brings to the table with data science. To me, that's the big component that, at a strategic level, a lot of these businesses have missed. The opportunity, that collaboration, not just within a data science team, but the data science team across the institution. And I think that if you really make an effort in trying to address how you, especially resource, in terms of infrastructure, frameworks, give the data scientists the places where they can deploy their code, where they can test it, where they can fail. It's important to give a data scientist a place where they can explore and they can fail without the world coming down. That should be a good start in terms of having some guidelines that will help us operationalize data science. And that's how we've addressed it. We're focusing on trying to create those platforms, those frameworks, automate as much as we can in terms of those deployments. Let the data scientists focus on what they're good at and forget about trying to figure out, especially all those little hidden demons when it comes to technology and platforms that clients are demanding more and more we use to deliver results, to deliver insights. I wouldn't say we have an answer for everything. We definitely not. We definitely don't. We don't even have a definition that we agree on. So personally, I'm really looking forward to see what this group can put together, because any sort of guidelines, best practices that we can generalize and send out into the industry, I think will help that decision-making process much more efficient, and ultimately, hopefully soon, cascade down to a much more efficient implementation and real takeoff of data science with industry.
A real pleasure to be here and to see you all. I think this is a wonderful development, the start of this section. I'm personally very enthusiastic, although I do speak to you as a dinosaur, a card-carrying dinosaur. And all this brings it back when I was struggling away to use classification trees in the 1980s, using S+ before there was even R to do things. And I spent a lot of time, working away on, cross-validation of prediction, regression models, whatever. And when this was just a corner that people weren't taking seriously or whatever, and I used to get grumpy about it, because the Royal Statistical Society, it's great, but you look down all those rows of old people, including myself, and it's a mixture between people who worked in official statistics, which is wonderfully important, and something I've got more and more respect for, and academics like I was, working academic statistics. And there's been this real gap, I think. And what's wonderful is the data science community is just erupting up and doing this fantastic work. So I'm personally very excited about it. But I do think that, stats, obviously, data science is not part of stats. Stats is a part of data science, and it's a very important core part of, obviously, as people recognize. And I do feel, as people have said, as data science matures as a discipline, I actually do believe that the Royal Statistical Society can play a very strong role in its growing that maturity as we're describing. Okay, the plug, I think the RSS, it's not just all these old people. It's actually, I think it's a wonderful organisation. My personal interest very much is in media engagement, in media profile, and campaigning. And we didn't mention, we had a wonderful success just now in that before the election, we don't take sides, but we use the election campaign as an excuse to complain bitterly about pre-release of statistics. The employment statistics, 140 people see them, all the spin doctors, everyone's seeing this stuff secretly before everyone else can see them, before the opposition see them or anyone sees them, this pre-release thing. And we got 140 statisticians and all sorts of prominent people to sign a letter to the Times, got a lot of media coverage about it, and we just heard it stopped. It's been, that pre-release of the employment statistics, yeah, exactly, amazing. And there was a real, a neat campaign, and working with Office of National Statistics, who mentioned in the letter saying we're not going to do it anymore, the letter in the Times and the campaign. So I just think it's a really important thing we can do. The other thing I'm very interested in is data in the media. The BBC, for example, is really growing its data science group within BBC News, and a wonderful, again, another great achievement of us at the RSS have an ambassador scheme, where we're training up young statisticians, early career statisticians, or even not so young statisticians, to become statistical ambassadors, to get out there, to perform in public, whether it's to schools, whether it's to anyone, an increasing number going on radio, of course, more or less, and other places, more on television. And we've just heard that the new BBC head of statistics is Robert Cuff, who's an RSS ambassador, a proper PhD statistician as the head of statistics in BBC News. It was, again, a wonderful achievement. So it's a really exciting time. It's almost the only bit of the BBC that's growing at the moment is their data visualization and data team. So I'm just sorry I'm so old. Actually, it's a shame because I really could have done with this when I was earlier in my career. So I think this is very exciting. And when we go downstairs, where I think it's going to be a bit cooler for a start, can I just encourage you to? We've got stalls set up for RSS membership, RSS conference. Go and talk to them. Just go and find out about the sort of stuff that's been doing. So can I just encourage you to do that as my personal plug? Okay, thank you very much indeed.
My name's Amjad. I work for Shell as part of Advanced Analytics COE, and we've heard all these had all these debates and these and thought about these ideas along the way. I have to say, we're in the midst of trying to produce a conveyor belt of data scientists. But actually, what I was kind of keen to question was, I believe data science is a collaborative affair. And if that is the case, then how do we treat people who say on job CVs they're data scientists?
Thank you. Who wants to answer that?
The point is that no one person can, fulfill computer programming, maths and stats and SME knowledge. So.
Yeah. Okay. So we've talked a lot about this. I mean, have you looked at a typical biochemistry syllabus for an undergraduate degree in biochemistry? There's a lot on there. I mean, there's seriously a lot of biology, chemistry, crystal structures, learning how to understand Raman spectroscopy. I mean, I don't think that data science is any different or more complex than that. It's just new. So in the early days of biochemistry, no one thought that was a real field. It really took the Medical Research Council to put a flag in the ground and say, this is a real field, and we're gonna fund it. We're gonna open institutes which are for biochemistry and molecular biology. It's the same. We just don't realise that yet. When we look back in history, well, there will be standard degrees, and it will just be a standard discipline, the same as any other discipline, I think.
Yeah, and I guess I'd expand on that a little bit. So, so my team at work are all technical people. They're all data scientists to some degree or another. But what we think of when we're hiring is saying, okay, everyone has to be basically okay in communication, in coding, and in statistical knowledge. However, each individual is going to have very different strengths. So among the team, you have to have great strengths in all of those. That team has to be able to work together, and to be a data scientist, you have to at least pass the minimal bar in those 3 key areas and then be great at least one. And that's how we usually think of it when hiring. I'd love great at all 3, but I can't afford those, so I have to have 1 or 2.
It's a real issue, right? I mean, in that, just your particular question, right, which is anyone can call themselves data scientists. I'm quite relaxed about it because I don't ask people whether they're a data scientist. I ask them whether they know Bayes' rule, right, and whether they understand what a hash map is. I mean, that's my rule of thumb as to what a data scientist is someone who knows Bayes' rule and what a hash map is, right? And if you can do both, you're kind of there. I don't ask them what their title was. I ask them what they know, and it's true that there's a distribution.
My name's Brian Gedala. I've been a fellow of the society for quite a number of years. I spent most of my career working as an unqualified actuary in the insurance field, and most recently working for the Financial Conduct Authority. I'm no longer employed there. I'm currently on sabbatical or semi-retired, or can't actually make up my mind what I want to do next. I want to congratulate you all. I think you're doing a fantastic job. I think the presentations today have been fascinating, interesting, and I think you're certainly headed completely in the right direction. But speaking as yet another dinosaur, and I make no apologies for acknowledging the fact that I am certainly a dinosaur and I can't do 3/4 of the things that you've been describing, I am a little bit worried. I hear you talk about clarity, strategy, implementation, but I didn't hear a great deal this evening about professional standards or ethics. You asked one of your questions, what is a data scientist's responsibility to wider society? But I didn't hear a great deal of answers to those questions. It's all very well papers being retracted several years after they're published. But if data scientists and statisticians, for that matter, are to move from the periphery of corporate bodies to the core of those corporate bodies, that isn't good enough. Because if work done upon which financial decisions are made have to be retracted because somebody didn't do their checking properly, you've got a big problem. Because if you're in a regulated industry, financial services, for example, somebody's going to go to prison as a result of that kind of mistake. That's not acceptable. I think I heard one mention of the magic words peer review. Now, I know, obviously, academic papers are always peer reviewed, but peer review should be a core part of everything that anybody does in a corporate environment. The RSS is a wonderful organization with a massive history. But in terms of its membership, I mean, I've got some numbers here because it's a subject I've been debating with the RSS for some time. 2002, there were 6,244 fellows and members and professionally qualified members of the society. By the end of 2016, that had actually fallen to 5,982. Now, that's only 0.5% over 14 years. So, okay, total membership, quite stable. But then you look at the professional membership, the chartered statisticians. 2002, there were 1,516 of us. At the end of 2016, just over 1,000. 31.5% drop in 14 years in professionally qualified members of this society. In fact, that's accelerating. 4.8% lost in 2014, 5.3% lost in 2015, 6.8% lost in 2016. 16% of the professionally qualified fellows lost in barely 3 years. Now, does that matter, you're thinking to yourself? Well, I think it does matter.
I'm really sorry, but can we ask you what the question was?
The question is, how is the society going to position itself to be the point of first call for professional data science? Because I think that's important. I think the society needs to establish some kind of professional status and professional standing that would make people who want to call themselves data scientists, because you're quite right, anybody can call themselves a data scientist, but the society needs to get into the position where those who want to be taken seriously as data scientists hold, hopefully, a professional qualification from this society.
Well, let me respond then.
Sure.
Which is, thank you for that. This session was about the industrialization and professionalization of data science. Data science is new, right, in some sense, and so our first step is to work out what professionalism means, and that's what this is all about. Is saying what do we actually mean by a professional data science career? And absolutely, we would love to get to a point where the Royal Society is the first stopping point for a data scientist. They want to become a data scientist, they become members, they go through some, that would be absolutely great. At the moment, data science is done by a bunch of kids in Shoreditch, right, who couldn't give a hoot. And that's partly because they don't know, and some of them because they come from a different background, maybe a computer science background, they've kind of picked up a bit of statistics on the way. Our approach with this is partly to think about what does professionalization and industrialization mean, but also to do that in a very open way so that we are relevant to these people who are using all these techniques, but perhaps are not part of a professional body like this that would give them some sort of structure within which to apply it. So all those things are completely taken. That is exactly what we are hoping will be a big part of this data science section.
We have lots of hands. I think this was Sophia was me first. Yeah.
I think a lot of people are feeling some trepidation of ethics and code of practice at the moment. And if you go internationally across the world, a lot of different organizations are asking that question, from the Royal Society to the IEEE to other professional organizations. I think what still follows at the bottom line is that law still applies. I mean, the GDPR has, for instance, changed to a right for explanation. What that exactly means, no one really knows at this point in time. But best practice will need to be developed in real situations, and that's something we can't totally preempt before it happens. But I totally agree with you that I think many people across the world are wondering exactly the same question, and I think it's part of the RSS to help to provide the expertise to answer that question, because we can't just answer them from an ethical or a legal point of view. It needs the technical understanding to come to a good ending point. But I would also say that we need the computer scientists to help us with it. We can't just do it as statisticians in the RSS. We need the additional technical expertise that they will also provide. So I think, yes, we need to get to an end point. In the meantime, the law still applies. You're not allowed to discriminate or be unfair, whether you're Google or anyone else, because it's against the British law, right?
I was going to move the questioning on slightly. I mean, I totally agree about the need for a professional body. From the 12 questions that were raised, speaking as someone who works in business, I would question whether it's the RSS's business to tell or even advise how data science should be organized and how it should be, how those teams should be structured within organizations. I would actually challenge whether people would know how to do that. But what I do think they should be doing is very much providing guidance around best practice and professional standards. So I would be interested in views on that.
So I think our feeling is that these are questions that businesses are asking, right? These, if you talk to anyone the people who are at the coalface of this actually are recruitment guys, because they're talking to chief executives about, chief executive has an idea, I've got to have a data science team, what do I do, right? And they're talking to recruitment guys, and the recruitment guys are going, well, I'm not quite sure, maybe I'll go and talk to some data scientists. There is not a common corpus of knowledge about this, of experience that's shared, because it's being done in little pockets. So the whole thing about, how does an organization do data science? That is not the whole of what this section is about. But I think it's a really important thing that we can become the we can help facilitate that conversation. It's a really important thing for us to do, because that will, in some sense, determine how effective data science becomes in our society. Most businesses have absolutely no idea how to do this. Absolutely none. That's my experience.
Sorry, just to add to that, why isn't the RSS the right place? I mean, why? Who else is going to do it? I mean, we're all managers. All three of us are managers or run data science organizations. We have more experience than anyone else has in managing data science teams, and building a function, and building strategy around data science. We're fellows of the RSS. Who else is going to do it?
Really enjoyed the talks today. I think the 12 questions are a great starting point for how we start thinking about fleshing out this new role, new career, new profession. My question or concern around it is, if we engage with those questions within this room, there's a risk of a self-reinforcement about what a data scientist thinks a data scientist's job is, or something like that. Whereas, we come up with our set of brilliant answers for the 12 questions and take it out to our stakeholders or the business or other people, and they can just go, that's not what we think of it, or that's not how we're planning to engage with you at all. How do we, at this point, engage people who are not data scientists in the process of finding out what that career or profession should be?
Yeah, that's a really good question. I think the last few questions have all hit on this challenge of this emerging area that's so interlinked to existing professions, but isn't of any one of them on its own. I think the question of saying how do you engage with stakeholders about what a data scientist is, I think we should learn from what the RSS has done in its past about how you engage with stakeholders in statistics, in what statistics should be, because there's an awful lot of good practice there. But yeah, I think you're right. That we have to take multiple perspectives. It doesn't sit with any one organisation perfectly. So the RSS is as a well-qualified organisation to take a stab, is doing so and trying to figure out this new important profession. But it's non-simple, and there are going to be a lot of fuzzy edges around all of these questions because they all reach into so many different specialisms.
I mean, the idea of tonight and future events and all of the social media touching points that we have is that you can give us ideas for how to do that. We really don't know.
Hello, I'm Alan Brimacombe, University of East London. Thank you for organising this meeting. I just preface what I'm going to say in case I come across as being anti. I'm not anti. I run a professional doctorate in data science, which recognises both the practice dimension and the science dimension. But the term science is the thing that I have a little bit of difficulty with, because it implies a discipline, and Sir David mentioned, emerging discipline. And for me, a discipline has a distinctive research agenda that separates it out from all other disciplines. And I don't quite see it happening yet. And the RSS, as a learned society with peer-reviewed journals, etc., ought to have a fairly clear view on, what is the distinctive research agenda. Now, we've had some ideas around, ethics and things like that, but these are not unique to what we might call data science. Okay, so it's that research agenda. Thank you.
That's a tricky one. The term data scientist, that's a problem, isn't it? It's the name that this emerging area has that we'll refer to it by, but there are often awkward conversations in which you say, we're doing data science, footnote, this is not the lab kind of science, it's quite different, it doesn't have some of those same disciplines attached. I think nonetheless there is an area of something which we're talking about, it has value, it is making impact, it clearly requires some professional standards, and that's what we're trying to get towards. I don't know that I would call it research discipline. My other panelists may frantically shake their heads at that, but there is a something there that we are trying to get some standards around, and I think that is the point of this discussion.
Oh, thank you very much. That was very, very interesting talks. My question is, assuming you find the answer to these 12 questions, what are the action steps forward of making those standards and answering those questions? How do you make the wider community sort of follow those or accept that those are the answers to the questions?
Well, you can't make people follow anything, right? But that's what this is about. What would you find useful? I know what works in other disciplines. Things like the Design Council, they have loads of case studies on their website. They have best practice guides. Works for the design. I don't know whether it works for data science. But what would you find useful?
This is a very good question. I think, do you start in education? Is that where you start building data science as a more concrete thing, or do you go into the industry and sort of develop that there, or where do you start?
Well, I think the starting premise of your question was, what is the answer? I don't think there's an answer to any of these questions, right? So each of them, if I think of an analogous question of what does a successful software project look like? That's something that's sort of understood. There are norms and principles, but you still can't write it down very, very simply. And I think data science, the answers to these questions is going to evolve in a similar way of good practices and accepted norms, but it's never going to be simple.
Follow-up question. Sorry if I'm taking all this time. How do we know we're heading in the right direction then?
If we start to have more impact, if we start to agree more on standards, if we can at least establish principles which we all agree on, that's the direction we're trying to head in, but I think it's going to be non-simple.
My answer to you from my perspective would be the output of this is a data science community rooted in the RSS. Right? This is in some sense, the 12 questions are an excuse to build a community talking about the right questions. And if we create that, then we're on the way to creating data science as whether you like the science or not. I'm not a massive fan, but that's what we call it, right? That's what we've got. What is data science? But data scientists doing data science and talking about it and doing it in the right kind of way. So if we can create that, if we can use this as an excuse to create a community, pivotal around here, then I think we're a success.
Yes, Bill Oxbury from GCHQ in Cheltenham, and I apologise, I came in late and I missed the 12 questions and I'm dying to not know what they are. But from what I'm hearing now, I'm sort of surprised to be hearing from the RSS as much uncertainty as I am about what data science is. And I'm even hearing you saying, well, you don't like the word science. And I sort of expected the RSS to be taking ownership of, the principle, the foundations of doing inference from data. And actually there was a beautiful article by David Donohoe recently called The First 50 Years of Data Science. It was for the Tukey Centennial, and he was drawing the history right back to the 60s. So why this uncertainty about the science?
Slightly circular now because David Donohoe quoted me in that article from a talk that I gave in this room. So, I think we are influencing already. We're trying to, we don't have the answers, but that's what we're trying to figure out, I guess.
I'm not uncertain about what we do, but different people might have a different view as to what science is. Some people think it is about a pure research function, and we're not about research. In some sense, we're engineers, right? We're building stuff. We're finding inference of stuff. What we call it is not really particularly important in my head. There's that. Do you remember Richard Feynman talking about, whether if you know the name of a bird in 6 different languages, does that make you know more about the bird or not? To some extent, data science suffers from a lot of navel-gazing about just the name. I'm not apologetic about what I do for a living and the inference that I do, and I don't think we should be. But what we call it may be problematic to some people.
I have a question for the audience. How many of you are actually jointly appointed in industrial R&D with production readiness and publishing papers in academia? Okay, so I think you guys should speak up more, perhaps. One of my points is I'm currently in the Department of Mathematics in Uppsala University, and I have a joint appointment at Combiant, which is leading about 200 Swedish industries owned by the Wallenberg Foundation, and my mission is to pump data scientists into Stockholm's data industry. And we will be hosting a similar event for the Kramer Society in August, so this is actually really good. So one elementary thing one could do is simply reverse engineer the highest salary schemes in Silicon Valley and Bangalore and so on, right? What do I mean by that? Just do some elementary GitHub operations and find out what exactly are the skills that get Netflix to pay the highest salary. And if you do that, it's quite simple. There are already industry standardized exams for the last 2 years one could take. In 45 minutes, you need to be able to speak 4 languages. I mean, SQL, Python, Scala, and so on. So it's actually solid standards and syllabus, and the rate at which you code is already there. So those who want to have such curriculum can easily hire statisticians who see themselves as a subset of data scientists, like David said, and actually do those exams first, right? That's a suggestion.
So I just want to thank the speakers again. And having run a data science group at a large company, I just want to reaffirm that I think these questions are really important. I think more generally, it's important to have thought leadership in this space. Number one, to be able to set standards, I think for entry, to have some clarification around exactly what data science is. But I think also the question of at the strategic level, how do we create the right frameworks to ensure for success in a commercial space? I think that's really the tough thing. I guess the question I would ask to the RSS is, what do you see the RSS, the role of the RSS in that being, in terms of, is it around the standards and how do we make sure it's robust, or is it around commercial success? Because I think those two things are very different. But I think, again, to your point, I think I totally agree from an entry perspective. It's almost simple. Well, you can, in a straightforward way, define what those entry requirements could be. But I think in terms of how do you ensure that you can spin up a team in a large organization and run it successfully at a strategic level, I think those are the really difficult questions which are still unsolved. I think to the question of name, I wonder whether we are at risk of falling prey to just popularism. At the moment, AI is a popular thing. I think increasingly it's becoming AI. Sorry, data science is a popular thing. I think it's increasingly becoming AI. So should we call ourselves statistical engineers or AI engineers? Who knows? But I think whatever it is, I think we do need some thought leadership around how do we do this well.
I just wanted to pick up on one point from that question about a syllabus is almost saying, you can find out what the things are that are popular and required right now by mining GitHub. That is very true. But if I look at it right now, I'll probably find being knowledgeable about TensorFlow right now will get you a lot of money from Netflix. Next year, maybe not so much. And I think the point of this kind of group is not to say what's cool right now, what is the most scarce skill. It's much more about saying what are things that we expect to be true for the long term, what are the underlying principles that we think are important. And those are slightly different questions, and I think they're the ones that we really need to be addressing.
Hi there. I guess if there are people here that are dinosaur, I don't know what I am, some sort of thing crawling out of the protozoan foam. But I actually did my doctorate before the term data scientist came out, even though I'm now in a role where I've been labeled with that. I came from chemical engineering. I went into doing statistics with big data for pharmaceuticals, not big data compared to my brother who works with back-end for video games that's true big data. And part of it is we're focusing a lot on the university side and people towards the end looking back saying what they want. But there needs to be guidance for people like me that are going, well, I have no clue what the hell my job actually is, because I don't fit into the data scientist that can code in 4 different languages. I know what I'm doing, but I just need help getting that accreditation to prove, hey, I do know statistics. I've been using it for years. I just didn't do a statistics course. And that's actually really important to me because I see people putting themselves down as data scientists, coming out of universities with data science degrees, who believe that the only type of average is the mean, which has me very concerned if they are working with missing data and those small errors where you have to deal with it, where they don't actually understand the very fundamentals of statistics. They just know how to make a piece of code run. So I'm really hoping that this focuses on and can get into those courses and actually say, hey, this course actually does have statistics to a degree where you can trust that the person knows what they're talking about. So that would actually be really beneficial from my point of view. But also, so from a hiring side, but also for my own career progression, because I don't have a career progression. I'm a chemical engineer working in marketing data now. And data science is the only thing that I can kind of attach myself to say, hey, my job is working with data, with different types of data. So I've gone from just numeric to working with NLP to all sorts of things. The flexibility, the interdisciplinary, that's really important. And I just wanted to voice another concern, which is the emphasis we're having on big data. Data science doesn't just have to be big data. It can be small data. It can be all sorts of things. It doesn't have to be just working with terabytes and petabytes and all sorts of things like that. So that's really just my thoughts on this.
Okay, I'm going to, I think, so someone sent me a question before we did this, sent it to me in the afternoon, but they can't be here today, so I thought that I'd read it out, and maybe now's a good time. Sorry?
It's together, I think.
Well, I think it's relevant to your question. It's about accreditation. The first half of your question is about accreditation. And he says, well, here's not a question. He's kind of answering your question, actually. He says, I'm not sure we should start gatekeeping who can or cannot be a data scientist. My worry is that official societies like the RSS might start defining and requiring particular certification to be something like a chartered data scientist. I think it would be disappointing if data science went down the same path. One of the best things about data science is the variety of backgrounds, and it would be a shame to change that. So there is a tension there, because lots of people don't really want that kind of accreditation. But then at the same time, I have lots of people who come to me and say, you know, I work in an organization, we're supposed to be data scientists, but then half these data scientists, they don't know what they're doing, and they don't know what, they don't know what a median is, and, what am I supposed to do? I'm a junior data scientist, I've got my PhD, I know that what they're doing is complete nonsense, but no one really trusts what I'm saying. But I don't think you need to necessarily have accreditation to do something about that. You can just write best practices and have something to point to. And people often email me and say, I saw your talk, I showed it to my boss, and now he thinks that I'm right. I mean, I'm just nobody on the internet, but because there's somebody saying something who sounds like they know what they're talking about, you can have some kind of authority or you can disseminate best practice in some way, I hope.
In some sense, this all comes back to the fact that we wrote up 12 questions and not 12 answers. We are not yet in the place where I think we're quite ready to say exactly who is and who is not a data scientist.
Detlef Nauk, I work in the research department of BT, and I think it's a very exciting event, and thank you for inviting me. And I think it's very important that something like this is being kicked off as a first discussion around what data science and data scientists should be. And I think about it, if you think about it in terms of science, if you do science and physics, for example, so you generate your own data, you run experiments, and you interpret the outcome in your own domain. If you compare this to a data scientist, they work on data that they haven't generated, and they help decision making in an area that they're not experts in. And I think they need to understand that they work with raw material where the scientific method should be applied to. And one of these things would be reproducibility. If you are a scientist and you have a theory, you think you have an effect, you know that you have nothing unless somebody else can reproduce the same thing. And these kind of principles, I think, the RSS is a great place to discuss this, because I think you guys are closest to this kind of idea, and you think about how things should be done. If you think about where this comes from, a lot is like computer science, where people think, what can we do with the kind of stuff that we have? And so I think it's a great kickoff to have these kind of discussions, and I think it's going to be really helpful for the industry.
My name's Eric. It's the first time I've ever been here. I agree fantastically with most of what the panel have said. Not so much with some other things. But the bit that I just wanted to pick you guys up on was the only bit that I disagreed with you on was the slightly disparaging comment about Shoreditch data scientists. So, I am fortunate to be the director of a small startup called the Data Analysis Bureau, and what we're trying to do is deliver data science as a service to client companies. So what you're talking about is basically our product. And I'd like to say that we're slightly ahead of the curve on you because we ran an event on exactly this about a month ago. So it's been quite nice to hear that sort of the things that we sort of came up with ourselves, you've kind of sort of affirmed for us, sort of reproducibility and all of that. So my question to you is, seeing as in fact some of us young ones, and data science as a field is a young thing, is sort of a young person's game, and we seem to be perhaps a little bit ahead, or at least at the same point as the eminent RSS, how are you going to engage people like us?
Look, I think it's a brilliant question. I think my point with my throwaway remark that I should be more careful of is that it's really important that this august institution does not become irrelevant to you guys, right? There are guys out, I'm going to call you kids in Shoreditch again, right? You're out there doing amazing work, right? Building amazing companies, doing really interesting things, sometimes publishing them, creating all this stuff. And if we sit here in this building and draw and build a big wall around what we call data science and say only people who we think are the right kind of people are allowed inside this wall, my guess is that some of the kids in Shoreditch are going to say, actually, that's something we're not interested in. And we're just happy at doing what we want, and we won't actually build a bigger community of data science. Because I think that there's all sorts of different communities doing this stuff in this city and elsewhere that are not necessarily all connected yet. We can be part of that, but not if we ignore people outside of the traditional zones that we look at, right? So my message to you and to the people you're talking to is, and the people who are working with you and all that is become part of this community on the Slack channel, get involved in the projects, these questions. I hope they're relevant just as much to you as to anybody else, and become part of that community, because the whole ethos of what we're doing is trying to reach out to lots of other people, not just in big business, but in small businesses, in academia, in government, to contribute to a proper conversation about how data science fits into the society. So your question is really important, and my response to you is the whole point of this is not to go away just thinking about one remark I made, but to go away thinking, you guys are invited, because you guys are absolutely as important as any other part in expressing what you think the future of data science is.
Oh, that's great. And I did unfairly use your comment as a great vehicle to get my question in. So, but it's really great to hear that, because, as far as we could see from where we were almost like the only people out there trying to sort of develop that sort of, thought leadership, become the place where, clients know that they're going to get a certain standard of data science service. So we're more than keen to engage with the RSS. And I think the RSS probably has a really great opportunity with ourselves, but also there are other companies out there I know trying to do similar things in sort of the nascent stages. There is a real opportunity to try and sort of be the focal point and be very relevant and bring us all together.
Yeah, and just to add to that, I mean, Martin and I are both data scientists, both running companies. Not in Shoreditch. Well, we're not in Shoreditch because it got too crowded. But yeah, it's very expensive. But yeah, so we're coming from this saying the RSS has an awful lot to say to data science, and that's why we're very keen to engage with it and to understand many, many years of lived lessons so that we don't try and reinvent the wheel. That's basically it.
Yeah, I can only completely agree as well with your comments. So I've run data science teams in 3 tech startups, one of which was in Shoreditch, so I am a Shoreditch data scientist. I'm not a kid. But I think you're right. I mean, I think you're right to be skeptical. I think the RSS
to some extent, does emphasize, big companies and big universities a bit too much. I agree with you, and I think that the more that people like you come along to this and engage in these discussions, we can, that voice will be heard. And I argue strongly for that voice to be heard. And I think that tech startups, tiny two-mans tech startups, could be way more advanced than major FTSE 100 companies in data science right now. That's where we are right now, and we need to recognize that.
Well, I'd actually say that I really agree with your point about the sort of academization of data science, if that's even a word, academization, because I think what it actually needs is some rigor. I come from an academic background, and in a sense, that's kind of like, I felt that was my USP to what I was bringing to the company and the way that we're thinking of trying to develop effectively what is our product. So, in fact, I don't want to discourage you, from trying to bring some rigor and some, structure and a framework. I think actually that's exactly what's needed, both for businesses trying to sell data science and those that are on the receiving end.
I mean, we certainly realize in the RSS that there are other organizations doing data science. Obviously, there's a Turing Institute. There's lots of meetups, so they're very successful. And we don't want to compete with those. I mean, they're very good things to do for data scientists. So the data science remit, which is here, which I forgot to present earlier, I think the heat got to me a little bit. But just to pull some things out of it, the idea is to be a professional body. It's not the professional body. So a professional body for data scientists. We're going to organize meetings for a broad range of attendees and to have some outputs. So we'll come on to outputs a little bit in a minute. But just to highlight some of the areas of what we said here. So promoting good practice by addressing what good data science looks like with examples. So we're not looking to define what a data scientist is or even define data science because we know there's so much controversy around that. So it's more about principles, best practices, and good examples. Promoting the statistical aspects of data science. We are a statistical society. We would be remiss not to focus on statistical methodology, but we acknowledge that there are lots of other areas contributing, but we do have a focus on methodology. We want to be a trusted voice on data science for employers. We see that as a gap. We want to support the data science community throughout the UK. I mean, this has been launched in London, but there's lots of data science going on all around the UK, so we want to be much broader than London. Support the pipeline of career development for data scientists and statisticians. So we're conscious of the fact it's not only providing maybe some training opportunities for data scientists, there's statisticians that want to know a little bit more about data science. And in fact, one of the sellout training courses we had this year saw that incredibly quickly was machine learning. So I think we also want to sort of spread the word around. And there are statisticians who would like to know a little bit more about what data scientists are up to. We want to support important emerging topics such as ethics, privacy, algorithmic responsibility and personalization, but also a little bit where the rubber hits the road on that, so some of the practicalities. Again, there's some very good groups around doing some research in these areas, but what are the practical aspects if you're a data scientist? And finally, fostering multidisciplinary connections and the exchange of ideas, and that's why we're here today, we're exchanging ideas. These are the committee members that I also forgot to present. So we've got a nice mix of people from academia, from industry, and also from government. So many people are here tonight, and hopefully you can mix with them a little bit later. So, thank you all for coming to the event. It's great to have a sort of a sellout in this heat, so we really appreciate you coming along to the meeting, and all the people that were involved at the RSS in helping us to organize it, and the committee members, but in particular for yourselves and the questions that you've raised, which are very interesting. Our aim was to get feedback from the data science community. I think that's what we've done today, so we'll take that feedback. And our aim is to involve the data science community. So how can you get involved? So the 12 questions that were presented, there's a much larger document of about 5 or 6 pages, which is available on GitHub at RSS Data Science. And basically, you can go on there and make comments. So we're giving a 2-week deadline to come back and make some comments on that. We'll also put the remit and all the slides on GitHub as well. And based on your feedback, we will then decide on what the priority topics are, because we can't address those 12 topics in one big go. And so we'll be interested to know what the priorities are and how we work together with the community on it. So we're going to determine the best way to engage. As you all seen, we have got a Twitter account, so we'll be putting more on Twitter and other bits of social media. So this is what a GitHub looks like, apparently. That's about it. Okay. So finally, there obviously people had more questions here. We have a reception kindly sponsored by Evolution AI down in the council chamber. So please do come along and join us for something to drink and carry on those discussions. So again, once again, thank you very much for your engagement, and we look forward to engaging with you over the next few years. Thank you.